Good morning, guys. We are continuing our videos on similar figures. Now, last video we kind of talked about what it meant to be similar figures, the definition. Now we're going to look at some properties and how we use similar figures. So, when we're looking at similar figures here, let me get out my pen. When what we're looking at is just like in congruency, we're looking for corresponding sides and corresponding angles. That's going to help us when it comes to writing out similarity statements. Now, the way I tend to do this is I try and start by marking sides here. First, I'm going to mark the longest side in each. So that would be BC and HE. We can see how those two sides correspond with one another. I'm going to pick the shortest side next. The shortest side here would be CD and EF. Now, with these, normally that's enough information, but I'm going to try and find another piece. I'm going to look for the second longest side. That appears to be AD and GF. And then lastly, we have AB and HG. By having some sort of color coding, or you can kind of use different textures, you could use dots and dashes, it really helps us when it comes to writing our similarity statements, which is difficult for um, when it comes to uh, like working with the congruency. So it's the same thing with similar figures. So what we're going to go through, it says circle all the statements that are true regarding similar figures. So first is we're going to be testing out the similarity statements. So the first thing I'm looking at is I'm going to check our letters. I can see A here is like G because it's between these two sides. So this A works and G works. B, right, is like H. B corresponds with H. C corresponds with E. And D corresponds with F. So this statement is true. We're looking to make sure all of those letters match up appropriately. Let's try the one below it. Does does F correspond with A? F is between this blue side and this pinkish side. A here is not. A is between this dark blue and the pink. So this is not a true statement. If the letters don't correspond, we cannot write them out that way. Next, we're looking at, does angle A, or is angle A congruent to angle G? And since they are corresponding with one another, it is true. Remember, corresponding angles are congruent. Sorry, that is not my best work. I'm getting used to this new pen here. There we go. Let's check out our next congruency statement. Next, we have B and H. I think that works there. We have C and E. C and E, those work. D and F and G and A. This one also works. There are more than one way to write out congruency statements. In fact, there's multiple ways. You just got to make sure that they line up properly because there are wrong ways to do that. Now, probably the most applicable and what's so different about about similar figures is how we utilize their sides. Now, when we're utilizing their sides, what we do is we try and figure out, well, I have do our corresponding sides set up. So first, we have side AB. Notice AB is blue here. I'm going to check, notice GH is blue. We have our two sides. Those two sides correspond with one another. That works. I need to make sure this proportion on the other side is also corresponding sides. So CD is this light blue, or I believe light blue, maybe teal. There we go. And EF is also teal. If you have the corresponding sides, notice the same color corresponding sides line up, then this is a true statement. And we can circle it. Let's try our next one. We're going back, BA, we're going back to this dark color. BA and HG, these two do go together, they're both blue. FE is our shortest side. Oh, let me undo that. And let's go to blue here. FE. Now, DC. Okay, so notice we do have the correct colors here, but notice one thing we didn't talk about here isn't within this triangle. If we look at this setup, this this top is both from the smaller of the two triangles, or sorry, not triangles, polygons. These came from the bigger. In this example, yes, I have the same colors, but notice this one is small on top. This one is big on the bottom, right? So in this case, this one is the big over here and small on the bottom. This proportion doesn't match up. You need to make sure, one, that you're using the corresponding sides, but also that they line up with the corresponding triangles as well. So make sure you snap a picture of this because this is going to be really helpful for when we start looking at some other examples here. So let's look at writing some proportions here. Um, Here we go. So you'll notice it says find the values of x in order to make, we're looking at number 5, to make the figure similar. So it's really nice with when we're looking at rectangles because there's only two different side lengths. What I'm going to do is I'm going to start by marking our long sides first. Our long side here is CD, and the long side in the other rectangle is JK. If we look at the short side, and the small is KL, and the small side here is BC. This is going to be really helpful for us when we go to write out our proportion. Now first, let's use these blue sides. We're going to put I'm going to mark our green sides over here. Oh, erase that. We're going to mark our green sides over here. Our blue sides over here. Now, I try and be as systematic as possible. I normally put the smaller on the top and then the larger on the bottom, shape-wise. So, if I'm looking at the smaller shape, which would be down here, notice that longer side. Let's do the blue side first, like we have marked as 24. Now, the larger side from the larger figure is 57. For the green sides, the smaller side is 8. And the smaller side on the other is x, what we're trying to find. So when we're setting up proportions here, again, oh, it is 8:30. So when we're setting up proportions here, it's really important. One, have the corresponding sides as the fractions, and make sure you have the same shape on top. Notice the smaller JK, we use this JKLM, JKLM on the top. Make that L look a little bit better. And on the bottom, we use this BCDA. Right? Make sure you're using the same shapes on the top and on the bottom. All right. Now, in order to solve this, pretty straightforward, we just cross multiply. So we get 24x is equal to 8 times 56. Sorry, 8 times 57, which is 465. So 24x is equal to 456. We divide both sides by 24, and we get x equals 19. So I'm going to mark that right up here. 19. So that's how we use a proportion to set up our missing sides. Now what I want you guys to try and do is let's see if you can set up the proportion for number 6. So why don't you pause the video and try and set up that proportion. All right, hopefully you tried that out. So first thing I'm going to do, I'm going to mark my sides. Long side here, long side here, short side, short side. Using these color codings or dotted lines and dashed lines is really going to help with the setup. So I'm going to do the same thing as before. Green's over here, blue's over here. And I am going to use the smaller figure on the top, larger figure on the bottom. So that's going to be the smaller figure blue is 18. The smaller figure green is X. The large blue is 72. And the large green is 12. Now I want you to pause the video and see if you can cross multiply and solve here. All right, hopefully you got it right. Let's check it. So we get 72x is equal to 18 times 12. So 12 times 18 is 216. So 216 is equal to 72x. We divide both sides by 72. And we get x equals 216 divided by 72 is 3. And I'm going to label that in my diagram as well. I'm loving this new pen I got. It's really going to up my teaching game here. So make sure you get a little snapshot of that. I think it's going to be helpful. Well, all right, guys, that's our second video on similarity. I hope you found this helpful. Make sure you're keeping up with these videos. Make sure you're keeping up with your work. And make sure you get a little time to yourselves, all right? I hope you guys are doing well. Miss you a ton. I'll see you guys next week.